Okay, so Acho, in the last class, if you remember, we were talking about some electrolytic cells, and we know that we are doing electrolysis nowadays. So we talk about molten solutions electrolysis. We talk about molten solutions in the last class and in last classes, some of the classes. And we also talk about aqueous solutions in the last few classes. Aqueous solutions, and we know that we talk about concentrated aqueous solutions and we talk about diluted aqueous solutions. These three types of electrolysis using inert electrode we will talk about. We were talking about, right? Inert electrodes. Inert electrodes mean we were using carbon electrodes or we were using graphite electrodes, right? They are not going to be utilized during the electrolysis in last few classes, right? And we know that if you talk about molten solutions, so if I just consider molten NaCl, so we know that, but so if we are doing molten solutions, so we just have two types of ions. The one is sodium ion and the one is chloride ion. Whatever salt you have, the ions are present over there, the same, right? And we know that the one which is positive, it will move towards cathode. Cathode attract the positive one, all right? So it will attract sodium ions towards itself and the plus one electron and form sodium metal. And if you talk about anode, so we know that anode attracts negative ions towards itself. So it attracts chloride towards itself. Loss of electron will be occurring, it will form chlorine, and chlorine is from group number 7, so it will always Cl2. And for this, we should have two chloride ions which lose one electron each. This is what molten solutions that were very easy for you. And if you talk about molten solutions, after that molten solution, if you talk about concentrated aqueous NaCl, so along with the salt ions, we were having water ions as well, which are H positive and OH negative. And if you talk about cathode, Bacho, so we know that cathode attract positive towards itself, and right now we have two positive. So anyone which is less reactive will move towards cathode. You need to keep remember the less reactive will gain electrons over there. And so hydrogen is less reactive, so it will receive electron and form hydrogen gas. So for this, we should have both of these two. And if you talk about anode, so we know that the one which is in greater quantity will go over there. So at anode, right now the salt is concentrated, so which means salt is greater, so anion is greater, which is present in salt. So chloride will go over there. By the loss of two electrons, chlorine gas will be formed. This was concentrated solution. And if you talk about diluted ones, so again, aqueous diluted NaCl have the same number of ions over there, which also have what sodium ions, chloride ions because of the salt present over there, and hydrogen ion and hydroxide ion due to the water. And we know that always cathode attracts positive, and when you have more than one cation over there, so the last reactor will form product. So it will form the same product as in concentrated one. But if you talk about anodes, so anode attracts the negative charges, and if you have two types of anodes, so the first possibility is the one which is greater will form products. So right now we have hydroxide in greater quantity, so it will lose 4 electrons and form two water molecules and oxygen gas, which is the product right now, which is going to be released. Right, Bacho? So these are the things that we were talking about in the last class, right or not?
Yes, sir.
Yes, sir.
I just want to show you one more thing over here. I just want to include one more thing over here in aqueous solutions. If you talk about aqueous concentrated, if you talk about the choke right over here, if you talk about aqueous solutions we are talking about, right? So if I talk about aqueous solution of sulfuric acid, so we should have concentrated sulfuric acid, we should have diluted sulfuric acid to understand this betterly. But we just need to keep remember over here again, we have same number of ions, right? So if you talk about number of ions, so we have H ions of sulfuric acid, we have two H ions, and we have one sulfate ion as well, and also water over there, so H ion of water and OH ion of water, right? The same ions over there as well in dilute solution, two H ions of sulfuric acid, one sulfate ion, one H ion, and one OH ion from water. So over here, it is very easy for for us to identify the product at cathode because we don't have any other ion other than H positive ion. So the product is same for both of them. Hydrogen ion will receive electron and form hydrogen, and it's always diatomic, so it will be like this. That's all. Cathode is very easy for us, but also anode is very easy for us once we have sulfate ion. So what you remember this: if you have sulfate ion, in any solution, so the sulfate ion is not going to break down. It is very, you can say that it's highly reactive and it's very strong. It's not going to break down and produce product. So remember, whenever you find sulfate ion anywhere in the salt, so it is not going to break down. So once it is not going to break down, so definitely we just have hydroxide to form, and over here it is dilute solution, so definitely the quantity of hydroxide is greater, so it is going to form product. So in both the cases of sulfuric acid, when the solution is concentrated or diluted, in both the product, in both the cases, the product is oxygen. So 4 hydroxide ions lose 4 electrons and form 2 water molecules and oxygen gas. So water will remain in solution and oxygen will form a product. So definitely oxygen is and hydrogen is product in both the cases. All right. So you just need to keep remember whenever in any salt, when you have find the SO4 over there in their aqua solution, it is not going to break down and it is not going to form any product. Yes. कोई कुछ पूछ पाए?
Yes sir. सर मैं पूछ रहा था
जी
सर, ये वाला एक्चुअली मेरा इंटरनेट कनेक्शन डिस्कनेक्ट हो गया था, एक सॉल्यूशन वाला दोबारा समझा सकते हैं?
जी, I am saying that whenever you have sulfate ion, whenever you have SO4 2 minus in any solution, तो वो नेगेटिव आयन प्रोडक्ट बनाता ही नहीं, हाईली रिएक्टिव है, बहुत स्ट्रांग है, उतनी आराम से टूट कर प्रोडक्ट नहीं बनाता इलेक्ट्रोलिसिस में. जस्ट यू नीड टू कीप रिमेंबर दिस, व्हेनेवर यू फाइंड SO4 वो प्रोडक्ट नहीं बनाएगा, उसके अलावा जो दूसरा होगा वो प्रोडक्ट बना देगा. ठीक है?
ओके सर, थैंक यू.
चलें बच्चों, सो दिस इज नाउ योर टास्क. सो आई जस्ट वांट बच्चों कि आप मुझे करके दिखाएं. इसको हम एक्वा सॉल्यूशन ही बोलेंगे, तो कॉन्सेंट्रेटेड और डाइल्यूट यूज करने की जरूरत ही नहीं है क्योंकि दोनों तरफ प्रोडक्ट सेम ही बन रही है. सो कैन यू प्लीज डू मी अ फेवर? आई जस्ट वांट आंसर फ्रॉम योर साइड इफ यू कैन solve copper sulfate. Just do it quick. I want electrolysis of copper sulfate. Half of the questions are the part of this topic, so it is very important to know. Now let's see. This is what it is actually, the comparison between two things, and before comparing this, I am just going to show you one thing which is actually you did right now. आप लोगों ने अभी जो किया है, the same thing. It is actually electrolysis. आपने जो अभी किया है, आपने क्या किया है? It is electrolysis of aqueous copper sulfate. अभी आप लोगों ने यही, मैंने जो आपको टास्क दिया था वो था aqueous copper sulfate. अब using inert electrodes, आपने जो किया है using inert electrodes किया है. ठीक है? Right बच्चों? And you can even write the name of copper sulfate like copper to sulfate, because it is a transition metal, so you must need to show the transition state or the oxidation state of copper over here. And inert electrodes की जगह आप carbon electrodes भी लिख सकते हो, or you can even write graphite as well, because both are the same things. Right बच्चों? So we know that what are the ions over here? What are the ions over here we have right now? If you talk about the number of ions, so bachcho, we just have, so we have copper ion over here, right? Copper 2+ ions and sulfate ions, right? And because we have water molecules, so we have OH and H ions as well, right? So we know that at cathode there is always a product which is which is less reactive, because less reactive will gain electron first. So you can see this, between these two you have copper which is less reactive. Copper 2+ will receive 2 electrons and product copper metal deposit, right? So you can say the observation is pink solid deposit. The copper is of pink color, it is pinkish brown solid, so you can say that the observation will be pink solid deposit, right? If we talk about anode, so at anode we have two ions over here, and you need to keep remember if you have these two ions, which is one of them is sulfate and hydroxide. Sulfate cannot broken down, so it will form hydroxide will form product, so it loses 4 electrons and form 2 water molecules and oxygen gas. So oxygen is actually the gas which is forming, which is product at anode, and the water will remain in the solution. So you can write the observation according to oxygen gas. You can see that bubbles of colorless gas. You can see that bubbles of colorless gas. You don't need to write the name, right? And what about the solution, remaining solution or electrolyte? If you talk about electrolyte, so actually you need to know this, that copper to sulfate is blue in color, right? Copper to sulfate is blue solution. Copper sulfate is blue solution, right? A beautiful blue color, right? So if you are doing electrolysis, so what happened to the electrolyte? So you need to keep remember blue color is actually due to the presence of copper ions, because copper ions are transition metals, and we know that transition metals form colored compounds. So the blue color of the solution is due to the copper ions present over there. All right. So if the copper ions are moving towards cathode and they are depositing over there, that means the number of copper ions are decreasing from the solution. Right. So that is why you must need to see over there that the color of the solution is going to be fades. Right. So you can say that the observation, these are all observations, right? There's this observation, and also I'm writing observation of electrolyte over here. So what will be the observation? You will say that blue color of solution fades. Blue color of solution fades. And if someone asks you, or examiner asks you the reason for this, so you can simply say that actually the concentration of copper ions decreasing from the solution. Once the copper ions are decreasing from the solution, so it must decrease the color of the solution. Is that right, Bacho?
Yes, sir.
So if you talk about the name of the product, if examiner asks you the name of the product, so you can say that even over here the remaining product के बारे में अगर वो पूछे, you can simply say that what will be the names of the products. You can say that, sir, over here it is a copper metal which is depositing, right? And over here the product is actually oxygen and water, but the one which is liberating and emitting from the electrode is actually oxygen. And over here the remaining is actually H ions plus sulfate ions, so it must give you sulfuric acid, H2SO4, right, बच्चों? This is what you need to know. You already did right now. ये आपने मेरे समझाने से पहले कर लिया है, right, बच्चों?
Yes, sir.
चलें, तो अब हमें जो नई चीज करनी है वो क्या चीज है बच्चों, जो हमें नया करना है? It is actually again the electrolysis. It is again the electrolysis, and again it is the electrolysis of aqueous copper sulfate. It is actually the electrolysis of aqueous copper sulfate again, and the name is again same, copper to sulfate. And the only difference is this: you are going to use reactive electrodes now for the very first time in your this chapter, using reactive electrodes, and right now the electrodes that we are using is actually copper electrodes. You are using copper electrodes right now in this example, right, Bacho? This is the very first time we are using what? Reactive electrodes over here. So there will be the comparison as well, because it is very important to remember, otherwise आप लोग जो है mix up कर देंगे. The comparison याद रखना जरूरी है. Say it. So first of all, if you talk about the number of ions, if you talk about the ions over there, बच्चों, तो ions कौन-कौन से होंगे इसमें? बच्चों कौन-कौन से ions होंगे हमारे पास यहाँ पर? Again, the ions are remain same. Yes, we have copper ions over there. We have the sulfate ions over here because we have copper sulfate right now, and we have hydrogen ions over there because of water and hydroxide ions, right? Right, बच्चों, the ions are same. And if you talk about cathode, so cathode बेचारा बहुत शरीफ है, ये हमेशा सेम रहता है. अगर इसमें molten solution है तो it attract positive towards itself, और एक ही solution में एक ही positive है तो वो ही बना लेगा product. और अगर कोई सी भी condition है, if you are having concentrated solution, dilute solution, sulfate solution, if you are having reactive electrodes, if you are doing electroplating, whatever you are doing, the less reactive will go over there. The less reactive will always go over there. So बच्चों, over here positive ion move towards, you can say that less reactive positive ion. So over here, out of these two, we have copper, which is less reactive. So it will go over there, receive 2 electrons, and form what? Copper. And again, observation will remain same because copper is depositing. So you can say that pink solid deposits. And again, the product is also same. So you can say that copper metal. Right, bacho? So these all things are same. This is reaction at cathode, right? This is observation at cathode. This is product at cathode. Right, बच्चों? The same, बिल्कुल same है दोनों में. सही है?
Yes, sir.
The only difference that we have over here is anode. Anode बहुत कम करता है. Molten है तो जो आयन वहां मौजूद है वो एनोड पे चला जाता है. कॉन्सेंट्रेटेड है तो जो ज्यादा है वो चला जाता है. डाइल्यूटेड है तो हाइड्रोक्साइड चला जाता है. सल्फेट भी है साथ तो हाइड्रोक्साइड चला जाता है. अब ये एक नई चीज आ गई, एनोड. If you just look at over here on the diagram, I am drawing over here. This is actually the container. Over here we are placing 2 electrodes and they are connected with the battery, right? This one is negative and this one is positive, and positive one is anode, which create problem all the time, right? तो कैथोड तो बेचारा शरीफ है, इसके साथ तो कोई मसला ही नहीं है ना, ये तो हर जगह सेम है. एनोड इज एक्चुअली गोइंग टू कॉज प्रॉब्लम ओवर हियर. सो बच्चों, एनोड पे होता क्या है आपके पास? वी नो दैट एनोड पे ऑल द टाइम देयर इज लॉस ऑफ इलेक्ट्रॉन. यही होता है बच्चों, राइट?
Yes, sir.
एंड वी नो दैट राइट नाउ अभी हमने इस पे जो मेटल लगाया है वो हमने कौन सा, ये हमने यहाँ पर मेटल लगा दिया, कॉपर मेटल लगा दिया यहाँ पर, राइट? हमने एनोड पर इससे पहले जितने भी हमने रिएक्शंस किए थे उन सब रिएक्शंस में वी आर प्लेसिंग ग्रेफाइट ओवर हियर, एंड ग्रेफाइट इज एक्चुअली नॉन मेटल, राइट? ग्रेफाइट क्या है आपके पास? एक्चुअली नॉन मेटल है, तो कोई प्रॉब्लम नहीं हो रहा था. वो इलेक्ट्रिसिटी प्रोवाइड कर रहा था सॉल्यूशन को, ठीक है ना? वो सब कुछ सॉल्यूशन को प्रोवाइड कर देता था. जो भी इलेक्ट्रिसिटी उसके पास आती थी वो सॉल्यूशन को प्रोवाइड कर देता था, बट खुद कुछ नहीं कर रहा था. बट राइट नाउ वी जस्ट प्लेस्ड मेटल ओवर देयर, एंड मेटल्स की प्रॉपर्टी होती है बच्चों के वो इलेक्ट्रॉन लूज करते हैं. इफ यू रिमेंबर अबाउट पीरियोडिक टेबल, तो ग्रुप 1 के मेटल्स होते हैं, एक इलेक्ट्रॉन लूज करके पॉजिटिव बना लेते हैं. ग्रुप 2 के होते हैं, 2 इलेक्ट्रॉन लूज करके पॉजिटिव 2 बना लेते हैं. ग्रुप 3 के होंगे तो 3 इलेक्ट्रॉन लूज करके पॉजिटिव 3 बना लेंगे. तो दिस इज एक्चुअली द एबिलिटी ऑफ मेटल्स कि वो इलेक्ट्रॉन लूज करके कैटाइन बनाते हैं हर हाल में. तो अब आपने एक तो मेटल की प्रॉपर्टी है इलेक्ट्रॉन लूज करके जो है आयंस बनाना, और आपने उसको ऑलरेडी पॉजिटिव इलेक्ट्रोड पे लगा दिया एनोड पे, व्हिच इज एक्चुअली हैविंग लॉस ऑफ इलेक्ट्रॉन्स ओवर देयर. एनोड पे होता ही लॉस ऑफ इलेक्ट्रॉन है और आपने मेटल वहां लगा दिया है. तो इससे पहले कि लॉस ऑफ इलेक्ट्रॉन सॉल्यूशन के थ्रू होता, पहले इलेक्ट्रिसिटी आ रही है एनोड के मेटल के पास, तो मेटल खुद ही इलेक्ट्रॉन लॉस कर देगा. इस वक्त लॉस कौन करेगा? मेटल खुद करेगा. सॉल्यूशन में जाने ही नहीं देगा इलेक्ट्रिसिटी. सॉल्यूशन में जाने से पहले ही मेटल अपना काम दिखाना शुरू हो जाएगा. तो एक्चुअली आपने मेटल लगाया हुआ है कॉपर. कॉपर खुद इलेक्ट्रॉन लूज कर कॉपर आयन बना लेगा, और कॉपर आयन बनाने के बाद सॉल्यूशन में डिसॉल्व हो जाएगा, यहाँ पर गिर जाएगा, यहाँ पर डिसॉल्व हो जाएगा, ठीक है ना? सॉल्यूशन में गिर जाएगा. इज दैट राइट बच्चों?
Yes, sir.
So you can say that copper dissolve. You will see in the reaction, in the procedure, in the experiment, you will see that जो आपके पास कॉपर का एनोड लगा हुआ होगा ना, वो आहिस्ता आहिस्ता डिक्रीज हो रहा होगा, वो आहिस्ता आहिस्ता खर्च हो रहा होगा, वो आहिस्ता आहिस्ता टूट कर गिर रहा होगा. This is actually you will find over there, and this is actually the observation, and this is actually the product कि वहां पर जो है वो क्या हो रहा है? कॉपर डिसॉल्व हो रहा है. ये प्रोडक्ट में लिख लेंगे और हम ऑब्जर्वेशन में लिख लेते हैं साइज ऑफ एनोड डिक्रीजेस. हम ये लिख लेते हैं साइज ऑफ एनोड डिक्रीजेस. You will find the size of anode decreases over there. So this is the reaction. जो कि आपको याद रखना है. This will be the you can say that the product, and the last one will be the observation. ठीक है बच्चों? जी.
सर साइज ऑफ एनोड डिक्रीजेस सही हमेशा होगा, लाइक कोई भी एलिमेंट हो या कोई भी
अगर आप कोई रिएक्टिव मेटल, अगर आप कोई रिएक्टिव इलेक्ट्रोड लगाते हैं तो वो जो होगा वो मेटल होगा. रिएक्टिव इलेक्ट्रोड डेफिनेटली मेटल का बना हुआ होगा, और जब वो मेटल का बना हुआ होगा तो वो लॉस ऑफ इलेक्ट्रॉन करेगा खुद भी. जब वो लॉस ऑफ इलेक्ट्रॉन करेगा खुद भी तो डेफिनेटली वो जो है डिक्रीज होगा, अगर अगर आपने क्या लगाया है, रिएक्टिव इलेक्ट्रोड लगाया है. ठीक है. नाउ लेट्स टॉक अबाउट इलेक्ट्रोलाइट, जो के पेपर में बहुत ज्यादा आता है. इलेक्ट्रोलाइट की ऑब्जर्वेशन. इलेक्ट्रोलाइट की ऑब्जर्वेशन क्या होगी बच्चों, ये जानना बहुत जरूरी है, बिकॉज ये पेपर में बहुत ज्यादा आता है. Just look at over here on the diagram. We know that the blue color of the solution is due to the presence of copper ions over there. तो अगर कॉपर आइंस की वजह से ब्लू कलर आता है ना, कॉपर आइंस की वजह से ब्लू कलर आता है या जाता है, तो इससे पहले वाली जो आपका जो प्रोसेस था उसमें कैथोड पर डिपॉजिट हो रहे थे कॉपर आइंस, और कहीं से आ नहीं रहे थे, बस जो थे वो जा रहे थे. अब जो प्रोसेस आपके पास है इसमें कैथोड पर डिपॉजिट भी हो रहे हैं और एनोड से आ भी रहे हैं. सो इफ वन ऑफ द copper ion deposit on the cathode, so one of the copper dissolved from the anode to become copper ion as well. So you can see this, the number of copper ions in the solution will remain same, है ना. सॉल्यूशन में जो आपके पास aqueous copper sulfate है यहाँ पर, इसको कुछ नहीं हो रहा. इसमें से अगर एक यहाँ जाता है तो एक वापस आ जाता है, एक डिपॉजिट होता है, एक डिसॉल्व हो जाता है, एक डिपॉजिट होता है, एक डिसॉल्व हो जाता है. सो द ऑब्जर्वेशन विल रिमेन, यू कैन से दैट द blue color of the solution will remain same. Blue color of the solution, blue color of the solution remains same. और अगर आपसे कोई इसका रीजन पूछता है तो you can say that the concentration of copper ions remains same. concentration जो है आपके पास कॉपर आयन की वो चेंज नहीं हो रही है, इस वजह से आपके पास कुछ भी नहीं हो रहा कलर को. Is that right बच्चों?
Yes.
Yes.
So if you want to draw a graph for this, so you can even draw the graph for this. कैसे बनेगा इसका ग्राफ? For suppose if I talk about the graph, for suppose हम बात कर रहे हैं mass at cathode. Mass at cathode की अगर आप बात करें और it should be the time, so what will be the graph? बच्चों, we already have one electrode at cathode which is made up of copper, which is made up of copper. So this is cathode, it is already made up of copper. You can say that this should be pure copper for suppose. This should be pure copper for suppose, because we want to deposit copper on the cathode. So अगर हम उसको copper को deposit कराना चाह रहे हैं और हम कोई फॉर एग्जांपल आप कोई इलेक्ट्रोड लगा रहे हैं जो कि खुद कॉपर का नहीं है, तो बाद में उसको प्योरिफिकेशन के लिए भी हमें लगाना पड़ेगा, कुछ और हटाना पड़ेगा. तो बेहतर ये है कि हम पहले से ही कॉपर लगाते हैं ताकि प्योर कॉपर हमारे पास जमा हो जाए. देखिए वी ऑलरेडी हैव कॉपर इलेक्ट्रोड जिसका कुछ ना कुछ मास है, उसके बाद फिर इलेक्ट्रोलिसिस से इसमें मास इंक्रीज हो रहा है. तो द ग्राफ विल बी लाइक दिस, राइट बच्चों? राइट.
Yes.
Yes.
Then if you talk about anode, so for suppose we have anode which is made up of impure copper. For suppose हम इसको प्योर करना चाह रहे हैं ना, तो ये इम्प्योर कॉपर है, इसमें और भी मेटल्स मौजूद हैं, तो इसका मास जो है आहिस्ता आहिस्ता क्या हो रहा है, डिक्रीज हो रहा है. और ये जब तक डिक्रीज होगा जब तक इसमें से सारा कॉपर निकाला जाए. ठीक है ना. दिस शुड बी मास ऑफ एनोड, मास ऑफ एनोड और टाइम, राइट बच्चों? Is that right? Every one of you? Yes. Now this one, but so if you talk about the graph over here at cathode, so over here is actually you can make a graph of mass of copper. आप बना सकते हो mass of copper का cathode पे at cathode, because you need to keep remember initially this is actually inert electrodes. You have graphite electrode, it is not copper electrode, so the mass will start from the zero, right? if you draw a graph over here, like if you want to draw a graph mass of cathode, so you can start with the center, because cathode का मतलब ये हुआ कि इसके अंदर फिर हम graphite का mass भी add कर रहे हैं, right? And over here, if you talk about the mass of anode, if you talk about the mass of anode, see, we know that we just have oxygen gas releasing from here. There is no loss and gain at this electrode, so the electrode will remain same. Right, Bacho? Is that clear?
Sir, can you repeat the cathode portion?
Which one?
The cathode at inert.
Graphite wala.
Yes.
Actually, but you need to see this when you talk about the electrolysis of copper sulfate using inert electrodes. So inert electrodes are actually made up of graphite now. So if you are drawing the graph, time versus mass of cathode, so mass of cathode means it is a sum of graphite plus copper, right? So definitely if you are depositing copper over there, so the mass of cathode increases, and initially you just have the mass of graphite over there as well, so it will not start from the zero. But if you talk about the mass of copper, so definitely the electrodes are made up of graphite, so there is no copper initially. So once you will start electrolysis, the mass start from zero. So that is why the mass of copper versus time will be starting from the zero, right? And if you talk about mass at anode, so mass at anode is not going to be affected, because the electrode is not going to be consumed, and even not the mass is increasing due to the deposition of any metal over there as well, right?
Yes, sir. Thank you.
So, Bacho, this is the most important slide right now on the screen. So you can copy this, or you can take a snap of this